Hello everyone, this is Ritesh. I'm a Cisco voice engineer and currently working with Cisco. I'm a stack engineer as well. So, welcome to my YouTube channel. I'm yet to give a name to this channel, but here we would be discussing everything and anything related to Cisco voice gateways. So we'll start with the basics. What are the different type of voice gateways? What are the function of voice gateways? PVDMs, various call flows. We would also discuss in further classes about various call control protocols like SIP-MGCP, H323. We would look at the call flows of these various protocols and also the types of debugs that we have to collect in various scenarios, how to analyze those debugs. And we would also discuss Cube. Right? I would be adding some more topics as the class will proceed. So today we'll start with the basics. So let's start with the slides. So this would be the topic roughly, yes, and yes, we would be discussing the TDM leg as well. T1, E1 PRIs, FXO, FXS, we'll be discussing those as well, and dial peers. So this will be roughly the topics that we would be covering. Today I'll start with the basics of voice gateways. So uh, when we say voice gateways, so what do we understand by a voice gateway, right? So if you go by the definition, right, a voice gateway is one of the most important components within a voice over IP, VoIP infrastructure, right? Why it is important, we'll come to know. Voice gateway is used to connect the enterprise VoIP network with the telecommunication provider, and it can use the various number of different connectivity methods such as PSTN, SIP, which is IP, right, which will make it a cube, right? So why voice gateway is important is it is important because it connects your enterprise infrastructure or your company network to the outside world, to the external world. It acts as an intermediate, right? So a voice gateway can connect to various enterprise to the external world using this T1 E1 lines, FXO, T1 CAS, E1 R2. These are the various connectivity methods that can be terminated on a voice gateway, right? So if your company needs a call to be made outside your company infrastructure or company network, you need a voice gateway. That's why it's very important. Without voice gateway, you won't be able to make calls. Of course, there are limitations, exceptions actually, where your call manager may connect or can connect to the provider directly using SIP, which is very rare. Out of my complete 7 years of experience, I have seen only one customer using that, where that customer was connecting to the provider directly from call manager using SIP trunk, right? But only one customer. Rest customers I haven't seen. They use voice gateway or a cube to connect to the enterprise a network, connect enterprise network to the outside world, right? So that's why the voice gateway is very important. Now, what makes a voice gateway a voice gateway? Voice gateway is a simple router, and there are various generation of routers, but a component called PVPM, Packet Voice DSP Module. So D stands for DSP, Digital Signal Processor, right? So it is the important component which helps you in converting, you know, your and talking from one leg to a different leg. It can connect your IP leg to a TDM leg. It can do the conversions. It can help in media functionings, media resource functionings like transcoder MTPs, right? But the main is to convert the audio, right, from IP packets to the TDM leg, right, which is the circuit switch network. And your IP side is a packet switched network. We'll look at the various call flows as well We'll see which is the IP leg and which is the TDM leg. So 2800, 3800 routers are generation 1 routers, and they support PVDM2. 2939 support PVDM2 and 3 both. ISR 4Ks, which are 4400 and 4300 routers, support only PVDM4 and SMX. SMX. So if you see, this is a PVDM4 as far as I remember, and this is a PVDM2 or 3. It looks like a RAM in your computer, right? And the chips inside it, these are DSP chips. So digital signal, this is the important component of this module, the DSP chip. Okay, so various PVDM has various number of DSP chips, and those are important. And DSP helps you in converting your audio from one form to other form. Right? We will also talk about troubleshooting the DSP related issues in next classes, the future classes. So let's move to the next slide. Now, this is an important slide. This is very basic but very important. Generation of voice gateways, and why we have to understand, we'll get to know in future slides. Right? So there are three generation of routers: generation 1, generation 2, and generation 3. So generation 1 or G1, generation 2 or G2, and generation 3 or G3. So 28, 3800 routers are generation 1 routers. These routers are end of support, end of life. What does this mean? Cisco is no more supporting these routers, neither the hardware nor the software, right? So if you have a 2800 or 3800 series routers in your company, and if you face any issue, and if you open a tax case, tax won't be supporting, helping you on this until and unless you have some, exceptional contract or agreement with Cisco. Now comes the generation 2 routers. 29 and 3900 routers are generation 2 routers, and generation 3 routers are 4Ks, 4300 and 4400 routers. Now, what's the difference? We'll see the difference between generation 1, 2, and 3, right? So 1, 2, platform-wise, architectural-wise, they are similar, right? But generation 3 or 4K routers are having a different platform, a different architecture completely, right? And that's why whenever you troubleshoot a voice gateway, you should check which router, which model router you're troubleshooting. Okay, we'll come to know that as well, why you need that. So if you see, this is the evolution of Cisco routers. I've started working since 2800, 3800. I haven't worked before that, and the models before that. So I've worked on 28, 3800, which came in 2004. I've worked on 29, 3900 routers, 2009. I've worked on all the versions of ISR 4Ks, which came in 2003 and 2014. These are the various 2800 and 38 series routers: 2801, 112, 151, and 3825 and 45. As I said earlier, these routers are end of support, end of life. These are 29 3900 routers: 2901, 112, 151, 3925, 3945. So if you see this 3900 routers, they are generally big. So when I say big, they are in 2 rack unit of size, right? You can insert and remove modules from the backside of this router. So it's big, it's 2 rack units. 2900 are 1 rack unit routers, but generally small, okay? Now, why we should understand, why we should know that on which router model we are troubleshooting or working, because this slide will help you understand that, right? So generation 1 and 2 routers are single plane architecture router. That means media and signaling both handled by the same plane, right? But ISR 4K or Generation 3 routers are called multi-plane or split plane architecture. Why? Because here media and signaling is handled by different planes. Your media is handled by data plane, which is called as forwarding plane as well. Signaling is handled by control plane, which is also called as route plane, right? So this is the main difference. And why should you be worrying about working on this different type of models is in the commands that you might be knowing that works on generation 1 and 2 routers might not work on generation 3 routers. Yes, there are command differences. A lot of commands are different and might not work on generation 3 routers or ISR 4Ks, which were working on generation 1 and 2 routers. So you have to be, conscious on that. That's why if a command is not working and you know that it works in generation 1 and 2 router and it's not working on 4K, you should Google. There are various support for Cisco support pages, Google articles, where you will be able to see the difference in commands. So this is that's why this is important, and you should understand on which router model you are troubleshooting. So uh, to summarize, generation 1 and 2 are single plane architecture, media and signaling handled by the same plane, but ISR 4K are it's a split plane architecture router, media and signaling handled by different planes, media handled by data or forwarding plane, signaling handled by control or route plane, right? So this is the basic major difference. Now we'll talk about various type of call flows. Why it is important to understand the call flow is if you are not sure or if you don't have knowledge of call flow, you won't be able to troubleshoot call routing issue. That's very important. So when I say call flow, you should understand where these type of protocols like H323 MGCP SIP comes into picture and where this PRI or FXO comes into picture. When I say comes into picture, between which two different items or entities it will be connecting, and these protocols will be running between which two different entities, right? So remember this H323 MGCP and SIP always runs between a call manager and voice gateway, and this PRI T1 E1 CAS FXO, right? They they will run between the gateway and the service provider always. This is called a TDM leg. This is called IP leg, right? So yes, so this MDCP H323 SIP, this will be running between call manager and gateway. So if someone says that I have a call flow of SIP and PRI, you don't have to ask where is your SIP connected and where is your PRI. So SIP would be between call manager and the voice gateway. PRI would be between gateway and the PSTN. If someone says I have MGCP FXO as a call flow, that means MGCP is running between call manager and the voice gateway. FXO is running between your voice gateway and the provider. We'll come to know what are different, what are FXO FXs, okay, where they terminate and what are they, right? So these are all possible call flows, right? You can have H323 PRI, MGCP PRI. You can also have a SIP PRI. You can have H323 FXO, MGCP FXO, and SIP FXO as well, right? So these are called voice gateways. Now, some two other possible call flows that we can have is you can have a SIP to SIP or H323 to SIP, but this is not called as voice gateway. I have seen a lot of engineers getting confused here. Yes, a voice gateway is a device which connects the IP leg to a TDM leg. Cube is a device which connects IP leg to a IP leg. So this H323 is also a IP leg, SIP is IP leg. So this will be a cube, Cisco Unified Border Element. It connects only IP to IP leg, and that's why it's referred as a cube. If your device is connecting a IP leg to a TDM leg, then that will be a voice gateway. Now, one major difference in voice gateway and cube is if you have cube IP to IP, like you might not need a PVDM card. You need it only if your cube will be performing media resource functioning like tran functions like transcoding, conference bridges, or maybe MTP. Then only you will need a PVDM. If you don't want to use your cube to perform any of such functions, that functions, you can avoid, you can avoid having a PVDM card. The cube can work without a PVDM card as well. It can help you, it will be working completely fine between IP to IP leg. Now, this last call flow, H323 to SIP, this call flow is possible but not recommended. These have a lot of interoperability issues. So avoid having this call flow. If you want to use the router as a cube and want to have IP to IP leg, use SIP to SIP. It's very easy to implement, easy to troubleshoot if you have any issues, right? It does not have any issues, any bugs, anything. There are bugs related to H323 and SIP because it has interoperability issues. So these are the various type of call flows. Now, you have to be clear in understanding the call flow. Whenever you are troubleshooting a call routing issue, an external call routing issue, maybe incoming, outgoing, ask the call flow to the customer, right? If they say I'm having a SIP FXO, that means SIP would be between call manager and voice gateway. FXO is between the voice gateway and the PSTN. So remember this possible call flows. Now, the various type of voice gateways. I mean, we learned about the generations of the voice gateway, but this is distinguishing as analog and digital now. So we already talked about digital voice gateways where you will have a T1, E1, PRI or BRIs or maybe a FXO. Those are digital, right? T1, E1, PRI. So those are digital gateways. Now, analog voice gateways where you have FXO and FXS. So an FXS is a foreign exchange station. FXO is foreign exchange office. What's the difference? These are the different type of analog voice ports, right? So I've seen a lot of engineers getting confused where the FXS terminates and where would be the FXO terminating, right? Remember this, someone told me, one of my senior, and I clearly remember the difference today as well. FXS generates powers and signal. FXO always receives power and signal, right? So FXS generates power and signal, and that's why if you take a FXO line or an analog line from the provider, FXS would be at the telco side. Cable would be coming from telco, which is connected at the in FXS port, and that cable would be terminating on the FXO side of the voice gateway. So that's why your telco will send the power and signal, and voice gateway will receive the power and signal. Right? One more classic example is, I'm sure everyone has seen the the landline phones. The landline phones have a small RJ9 or RJ11 connector connecting on the back side of the phone. As soon as you plug out, your phone powers off. As soon as you connect it, your phone will power on, right? Why? Because that connector is connecting to the FXO port on the back side of the phone, and it goes to the telco where it's coming from an FXS port. So your telco is providing the power, and it is supplied to the telephone or the landline phone using that FXO. So as soon as you connect it, it starts getting the power, right? So remember, on the back side of the phone, it's FXO port. At the telco side, it's FXS. So this is the difference. Remember, FXS generates power and signal. FXO receives power and signal, right? So these are the various type of analog voice gateways Cisco have. VG202XM, we all 204XM. We also have 202 and 204, but those are end of support, end of life. So we have 202XM, 204XM, 224, 24 VG310, 320, and VG350. I've worked on almost all the analog voice gateways. The it's so there are difference in the number of ports. 202 have two FXS ports. 204 4 FXS ports, 2 to 4 24 FXS ports. This VG310 and 320, 24 and 48 ports respectively. VG350 have 96 to 160 ports. Now it has range of ports. And what's the difference between the VG350 and rest of the analog voice gateways? In rest of the analog voice gateways starting from 202XM to 320, the ports are soldered in the router. You cannot remove them, right? They are soldered. But in VG350, it has blades on the back side of it, right? You can add and remove the number of ports. You can see there are 4 slots, the 4 blade kind of thing on the back side of the router. So each has, I think, maybe 48, 48, 48, 96, 96, and 40, 96, 96. Almost, I think, yes, each has 48. So I'm not sure on the number, but yes, you can use the number of ports as per your requirement. If you don't need complete 160 ports, you can only use maybe 2 of these blades and have 48, 48 ports, right? As per the number of requirements you have. So this can be removed and added. Now this VG350 is based on the 3900 router architecture, right? It is a 2-rack unit, a big size router. It looks like 3900 router, but it's an analog. Remember one more thing, these analog voice gateways cannot have FXO port. They will only have FXS port. You can use them to connect to analog devices like analog phone, fax machine, pager devices. So you can use them to connect to these devices can be connected to this voice gateway, right? On the back side of the analog phone, it will be FXO port, and the cable will terminate here in FXS port, right? So same as the fax machine, on the back side of the fax machine, it will be a FXO port that will terminate here in FXS port of the router. So it can only have FXS port, right? So this is the complete basic of the voice gateways. To summarize, voice gateway uh, are the devices which will help you in making and receiving calls to the external world, right? Acts as an intermediate between your company infrastructure and the PSTN on the external side, right? It can terminate uh, uh, a TDM leg on it. It can have a IP to TDM leg. It can have a IP to IP leg, which will be referred to as cube from by Cisco, right? And there are various generation of routers like generation 1, 2, and 3. So 28, 3800 router, 29, 3900 router, and ISR 4K, 44, 4300 routers. We also discussed about various type of call flows, right? You can have a MDCP 3 to 3 between call manager, SIP between call manager and voice gateway, and you can have a T1 E1 PRI, FXO, T1 CAS, E1 R2 between voice gateway and the provider. So these are the various type of call flows. Now, one thing that I would like to add in the analog voice gateway is you can use Skinny, SCCP, Skinny Client Control Protocol, which is Cisco proprietary between this analog gateway and the call manager. You cannot use a Skinny protocol to control PRI or FXO because it does not have that capability. Skinny can be used to control FXS. So you can use that to control FXS. So analog voice gateways, whenever you configure analog voice gateway, you can either use MGCP or Skinny only to control your FXS port. Well, I'll see if in further classes we can see the configuration of those analog voice gateways, right? Before we go, in the next classes, I'll try to log into one of my lab routers and will show you how to check the basic configuration, the inventory, what's the model of the router, what's the iOS installed there in the voice gateway, right? We can do that in the next class, right? So this is my first YouTube video in my channel. I would like everyone to comment. If you guys want me to discuss any topic related to the voice gateway, just comment. Even if it's not included in my predefined topic, I would be including it if it's related to voice gateway, right? And I would like subscribe to my channel, like channel, share it, and just let me know if you how would you like to rate this video, if you want to add, remove anything, uh, if you want me to change anything, to change the way I'm teaching, right? So I would be waiting for your comments, guys. Thank you, thank you for viewing my video.